in front of your book. When you have questions with this symbol, it means that you need to graph. When you have CAS like this, it means that you need a calculator or a computer algebra system to solve. This is a warning. When there is a warning, they will give you this sign. This tick also, you need to go to the website of the book. And also when you have a number, usually the numbers of the exercises are black. If you have one with red, it means that there is a hint, there are hints for this question available in the website of the book. This usually will be available for you through the web assign. They will activate it, I think, soon if it is not. Okay, in this slide also I prefer to put for you some issues that you need to recall. Also, you can find these formulas on the front, in the front cover of your book, and also on the back cover of your book. From algebra, you need to remember these formulas: the exponents, radical, and the absolute value, and the quadratic formula, the area, the volume of some well-known shapes, also the slopes, the circles, the equations, the graphs of trigonometric functions, the values of these functions. Also, the most important part is this: you should be familiar with the trigonometric identities. You will use these heavily in this course. And of course, the graphs of spatial functions, the well-known functions, the power functions, the reciprocal function. I think this is repeated. This section is repeated. Also, what else? Also the logarithmic functions, exponential functions, and also the identities of these functions. So chapter 2. In chapter 2, ya shabab, the main target of chapter 2 is the limits and derivatives. The limits and derivatives. But of course, we will study the derivatives at the end. Mainly, it is about the limits and the continuity of functions. So we will spend like 4 or 5 sections on the limits. 6 sections indeed. 6 sections about limits and continuity. And the last 2 sections will be about derivatives. So first of all, ya shabab, I think you still remember how to find the slope of a line. What you need to find the slope of a line?
2 points.
2 points. You need 2 points. And after that, the slope will be the delta y over delta x. This will give you the slope. Okay?
Mm-hmm.
What do you think? How to find the slope of a curve? If you have a curve, I think no more need for the camera, because I will use my pen. So let me turn my camera off. Next time, inshallah, I will ask you to also to open your camera. Also, I need to see you, to know you, and in every class we will try to open the cameras, inshallah, if that will not affect the quality of the internet. Okay. Also, let me remove my keyboard. Good. So to find the slope of a line, you need 2 points, and after that you will be able. طبعا, how to find the slope of a curve? If you have a curve like this, how to find the slope of this curve? Is it going to be unique? طبعا, here for the line, wherever the points that you will use, the slope will be the same. So the slope will be constant. The slope of this line is only one number. That's it. What do you think? Is this idea applicable for the graphs, for curves like this?
No.
Is the slope will be the same?
No.
No.
No, the slope at this point is not the same as here. Is not the same as here. Is not the same as here. The slope here is positive. The slope here is negative. The slope here is positive. The slope here is 0. You got my point, ya shabab? So now we will generalize the idea of the slopes. How to find the slopes of a curve? To find the slope of a curve, you need to find it at specific point, because it will differ from point to point. Now the question: how to find the slope of a curve at a point? This is the question. So when you have how to find the equation of the line, you know how to do that. This is the equation of a line if you have a point and the slope. This is called the slope intercept. The point slope form. Now, what is the difference between these two lines? This line is called tangent. Tangent is a Latin word, ya shabab, or a Greek word that means touching line. So this is a tangent and this is a secant. So when it intersect the graph at more one point, this is of course when it is intersected like this, even at one point. This is secant, intersect. This is tangent, touch. Okay. So now to find, by the way, in some situations you can have a line that is tangent and secant at the same time, like this. Look, it is a secant and tangent at the same time. Now, how to find the slope of the secant? It is easy. You have 2 points. You can find the slope. Now the question is how to find the slope of the tangent. You have only 1 point. You need another one. So what you will do? The idea indeed that if you start with a secant, let's say that this is a secant, and we want to find the slope of this line. So what we will do, we need another point. So we will try to take any other points, and we will make the secant becomes a tangent. So we will make this point move this way until it becomes here. I think we have a much graph here. Yes, a better graph here. Let's take this example. Find the slope of this tangent at the point 1 and 1. So what is the slope of this line at? We need to find the slope of this line at this point. I will show you later how to do it easily, but let's get the idea behind the tangent problem, because here we are talking about the tangent problem. By the way, in your textbook, ya shabab, you need only to study example 1. So only the idea that is introduced in example 1. Only. The others are excluded. They are not included. So now if you take a point now, it will be approximately not the same. So if you calculate the slope between this point P and Q, we will call it this MPQ, which means the slope of the line segment PQ. So the slope, according to the definition of the slope, will be delta y. It is delta y over delta x. This is delta y over delta x. This is the value approximately 2.5. If you take a closer point here, take a closer point. We started with 1.5. Let's take 1.2. If you use 1.2, square it, it will be 1.44. Now calculate the slope. Look what will happen. It will be 2.2. If you take more close, if you take another point, when you are close to this, you will get a better estimation. Look, for example, if you also take 1.1, this is 1, this is x equals 1. Take 1.1, this point. Here it is, it will be here almost. Here it is. Yes? Now calculate the slope. The slope will be what? 2.1. Look what happened. It is 2.5, 2.2, 2.1. What do you think? If we get closer and closer, what it will be? 2. It will be 2. 2. So if you take any x, arbitrary x, it will be x squared. This is the point. Now, this will be the slope if you have any arbitrary point, not necessarily a fixed point. So these are some values that you can consider. For example, if x is 1.5, 1.2, 1.2, until you are close, very close from 1, the value of the slope will be very close from what? From 2. So what we conclude from this, ya shabab, that the secant, the slope of the secant, the limit, when the secant becomes a tangent, the slope of it will be the slope of the tangent. And this will introduce you to 2 concepts. The concept of the limits and consequently the concept of the derivatives. So when Q is more close to P, the slope will be more close to 2. And these are, of course, explain the idea. When X is very close from 1, the point will be very close from P, and the secant will be tangent. The secant will become tangent, and the slope of the tangent of the secant will be 2 in that case. I think this is the same remark that we have repeated before. Now, we say that the slope of the tangent lines is the limit. This is the idea behind the limit, ya shabab. When you have something close, when we have a point that is going to be close and close, when we have x here very close to 1, this is the meaning or the idea behind the slope. Is the limit of the slopes of the secant, and we express this simply like this. The slope of the secant equals to the slope of the tangent. We use the first 3 letters from the word limit, L-I-M. We will write it L-I-M, but we will read it limit. So here we will read it like this. The limit of the slope of the secant when Q is approaching P equals to M. And this is, of course, the standard form of in general. We have found it in general that the slope, if you take any point here, x and x squared. Why x and x squared? Because y is x squared. If this is x, this is y. So y is x squared. Now, you can express this problem, this tangent problem, as a limit. And this is what we are going to do in math in section 2.2. So the slope of a tangent can be expressed as a limit. And for this idea to be generalized, and if you have the slope, you can find the equation of the line. For example, he asks here, find the equation of the tangent line to this parabola at this point. So you have a curve, you have a point, and you need to find the equation of the tangent line. The equation of the tangent line will be this one. You have a point, this is x1 is 1, y1 is 1. What you need to find is the slope, and we did find the slope, shabab. The slope is 2, so it is a matter of substituting. So if you simplify, this will be the equation of the tangent. So we have a curve, here we have a function, f of x equals to x squared. We have a point, which is 1 and 1. The question is, what is the equation of tangent line? What is the equation of the tangent line? It will be y equals to 2x minus 1, which comes from this formula. This is the main idea of section 2.1. If you will have a question from this section, it will be like this. طبعا we will use the techniques of 2.2 and 2.3 to solve such problems. Okay? This is an old exam question, for example. Find the slope. He wants just here the slope of the tangent as a limit, not the exact value. What will be the slope of this line as a limit? So we have a curve, we have a point. So the slope of this line will be the limit of the value of the function, as we did before. It will be what? As we did here, shabab. So let's assume that we have a curve. The curve is like this. So what we will do, let's say that this is the point 0 and 1. This is the point 0 and 1. Now what we will do to find the slope, we will take our arbitrary point here. So we will call it x and y. What is y? Y, it is what? E to the power x plus x. So what will be the slope, shabab? The slope will be the limit?
The limit p to
of y e minus, it will be the slope of e to the power x plus x minus
1.
Minus what? Minus y, because this is delta y. We have 2 points here, this minus this and this minus this. Minus 1 and x, this point, x minus this point, which is 0. Now this will be the limit when x is close to what? When x is approaching 0. And here it is. I think it's written here. Yes, here it is. It is written in much better way. Any question, shabab, about this? This is the limit of the function as a slope here in this case. Try to solve this, shabab.
دكتور أحمد.
Yes, please.
الآن أنت قلت لنا الليمت هو slope التانجنت ولا لا؟
The slope is the limit of the delta y over delta x. The slope of the tangent is the limit of delta y over delta x when x approaching 0, or when delta x approaching 0. You can think about it like when x approaching x0. If delta x it is x minus x0, for example.
تمام.
So it is when delta x, this is, you can think about it when delta x approaching 0. Okay. Now, again, ya shabab, try to solve this. Which answer is the right answer? By the way, what was the right? I forgot to mention which answer was right here.
C.
It is C. You're right. It is C. Now, what is the right answer here? Please, ya shabab, solve this one now. Do you have an answer, ya shabab, for this question?
Yes, D.
The answer is
D.
the answer is D.
C.
مين يزود يا شباب? We will see if it is C or D. What do you think? Is there other options يا شباب? The answer is C. This is the solution يا شباب. Forget about this. طبعا this is يا شباب, they are using here the rate of change. The rate of change, we will study it later. The idea is very easy. The idea is so easy. انت فكر انه مثلا هذه ايش هي كوساين سكويرد، يعني مثلا هذا الجراف حق كوساين سكويرد، وهاي البوينت اللي هي ايش؟ باي اوفر 4 والفاليو حقت الفانكشن وكوساين سكويرد باي اوفر 4. اوكي؟ Sorry, the answer is not C. I realized now.
Yes, D.
Because square, yeah.
Yes, I realized, yes. Now take another point here. The point that you will take here, it is x and what? And cosine squared x. So now the slope will be the limit when x approaching pi over 4. Here you will have delta y, it is this minus this, so it is cosine squared x minus cosine squared pi over 4 over x minus pi over 4. Now, what is cosine squared pi over 4 ya shabab? What is cosine pi over 4? Square root of 2 over
2.
Am I right? Square it.
Yeah. Half.
Square it. It will be 2 over 4, which is a half.
Yeah.
So this is a half. And the answer is D. You are right.
D.
The answer is D. Excellent.
Doctor.
Yes, please.
The second point, why we choose cosine squared x and the y?
You got the idea here that we will take a point, arbitrary point, like what we did here. Yeah, Shabab, don't worry if you didn't understand this section. By the way, even there is no recitation question for this. It is just the introduction section to introduce you to the idea of the rate of change and to the idea of the limit. You will take arbitrary point. Do you understand what I mean by arbitrary point?
Yes.
يعني انت بتاخذ نقطة عشوائية هنا، أي مكان، أي نقطة، فخذها أي نقطة x وكوساين سكويرد x و y. طبعا احنا نتكلم عن x و y. أي point on the plane it will be x and y. صح ولا لا؟ فwe take in not specific point, any point. But here we have a specific point. x here it is pi over 4. هنا راح يكون ال y اللي هو the value of the function at the y will be the value of the function at pi over 4. Is this answer your question?
Yeah.
Thank you. Excellent. Any question? Any more questions, ya shabab? Let's go to the next one. طبعا I don't think so that time will allow us to do all of these. So you need to practice by solving these, ya shabab, some of these exercises. And don't worry if you cannot calculate the limits. it is not this time. It is not appropriate to find the limits in this section. Wait until we finish the 2.3, 2.2, and 2.3, and after that you will be able to deal with limits. Like here, this question you cannot solve it in 2.1. So the idea of 2.1, it is up to here, just up to here. Or let's be honest. Yeah, and you can do it up to where? Up to here. No, it is okay. I think for this question, it's okay. For this question, it is a matter of simplifying, but evaluating the limit, I mean. Evaluating the limit from here up to here, you need to study 2.2 and 2.3. But you can do it up to here as a limit. طبعا you can take, by the way, another way. You can use a point as another way for finding the tangent. You can take the point and make the equation if you want to find the equation. Similarly for this question, Shabab. I will try to add more all the exam questions for the slides, so it will be also good for you to practice more. Any questions on section 2.1? If you have any questions, ya Shabab, I will be available during the office hours today, inshallah, from 12:15 until 1:15.
Teacher.
Yes, please.
Where can I find these slides?
I will upload them in the Blackboard, inshallah.
Okay.
Is that okay?
Yes, it's okay.
Okay, can we go, Shabab, to introduce you quickly to 2.2?
Yeah.
Okay, let's go to 2.2, not this one. 2.2, I just started today working on 2.2, by the way, Shabab. 2.2, here it is. 2.2 is about the limits of functions. So what is the limit? I think you feel the idea behind the limits from the tangent problem. Let's now investigate the behavior of this function when the values of x are near 2, not exactly 2. When it is 2.1, 2.2, 1.8, 1.9, and so on. We need to see what will happen to the function. طبعا we started with easy. This is easy because it is quadratic function polynomial, so easy. You can sketch the graph. This is a parabola at the end of the graph. So if you don't have an idea about the graph, if you don't know how to graph, you can use a table of values. You need a calculator, of course. So this is just for you to understand. You will not do that in the exams or in the quizzes. So you will start with, you will get closer to 2 log. You will start with 1.5 until you use 1.99, almost 2. Look what will happen to the function. It will becomes what? Almost what? So when this goes to 2, this will goes to what?
4.
To 4. Am I right?
Yeah.
Similarly, if you are using values that is greater than 2, for example, if you use 3, 2.5, 2.2, and you get closer to 2 from the right, upper than 2, greater than 2, also it will goes to 4. So we can express, by the way, if you sketch the graph of this parabola, this is easy, not difficult. This is the graph of this parabola. Look, when x approaching 2, when x gets closer and closer to 2, the y values, the graph itself is getting closer to what? To 4. So when x goes to 2, when x approaching 2, y approaching 4. Here it is. And we can, using mathematical notation, we can say that the limit of this function when x approaching 2 is equals to 4. I wish this clear, Shabab. And this will lead us to the initial definition of the limit. It is not the formal definition, by the way. We will take the formal definition in 2.4. Now, if you have a function that is defined or not, by the way, at x, it is not important to be defined at a. Just we need it to be defined near a, around it, not necessarily at a. This means that f is defined on some open interval that contains a, but not necessarily at a itself. It is not necessarily for the function to be defined at a, like this one. This one is defined at a. You can put x equals a here, Shabab. 2. You can put x equals here 2. It is defined because it is polynomial. The domain of polynomial is all the real numbers. You can substitute by any number. Now we will simply, by using this symbol notation, we will write it as the limit of the function when x approaching a is equals to L. This is how to read it. The limit of x as x approaching a equals L. Roughly speaking, this means that when x approaching L, when x